Um, Hello, everyone. I'm Yanling from Druid Technology. It's a great honor to be able to speak here to introduce the tools that we have to able to help the scientists on some great tracking project. Catalina has just introduced a lot about how to select the trackers for your project, and thanks very much. And now today I'm gonna focus on two aspects. The comprehensive is what we call the comprehensive tracking and how we assist the scientists to do fine behavior research. By comprehensive, we mean the ideal solution where you can get long-term and continuous data of multiple dimensions and high resolution and on a large sample quantity. For this, the ultimate technical limitation will be the size. With a big size, you can have endless power and all the sensors and modules you want, but this is not usually the case. So it's our job to design very efficient power management scheme, use algorithms to prioritize different data and compress data by onboard computing and reduce the cost. Well, for the users, to have an ideal tracking result, you need to select a suitable tracker and good deployment method. First, you will need to consider whether to go with a backpack or a leg band, a neck collar, or other. Each have its own advantage, and also what is your weight budget. Generally, backpackers offers the best solar charging efficiency and thus gives you the finest data. However, it requires skills in doing the harness. If improperly deployed, the device might fall off or cannot have its best performance, or even worse, the mortality could rise. And the collars and leg band are much easier to attach. After selecting the right models and deploy the method, you need to consider on the accessories. What size collar is good for my bird? Should I elevate my backpack to avoid the feather covering? How should I elevate it? Should I elevate the whole device or just the solar panel? These are very crucial details that determines your final tracking results. We've seen a lot of cases where very powerful models are used, but just unable to bring out the best performance. Sometimes the data value are dozens of times different. So to help users reduce such risks, we are designing multiple models with flexible deployment method and modulated accessories to fit different birds. The users make decisions when they buy them, and they also get some flexible accessories to do some fine adjustment during the field work. For larger or medium-sized birds, you will have a lot of choices among those full functional devices. They can be with different sizes and weight, and they have flexible choices for deployment style on neck, on back, or on the leg. And they can also be very small. This is the lightest GPS solar tracker, and starting from 5 grams, transmit via 2G, 5G, or Argos, and the cost is less than $1,000 US. This is an example of the data platform. As you can see, it is not an old era where you see all those plain text in white and black, but multi-dimensional data visualized in vivid forms. This is an example of a Lego that connects nearly 2,000 GPS a day. And this is not a selected case, but happens every day. With these tools, you can easily check and correlate the 3D GPS tracks with speed and height and the continuous activity rhyme and environmental conditions. And you might get some valuable conclusions and or interesting inference from that. When we come to even smaller sized birds, we don't want to make sacrifice on the data collecting abilities. So we have to remove the cellular communication module, which is more power consuming. So we use an alternative transmission method. Then we are able to make long life GPS trackers weighs from 2.5 grams. This has been used on many turns in Asia, Europe, and New Zealand. And the new version is in design right now. Hopefully it will below 2 grams. So when we have this, birds that weighs around 6 grams will be able to track with years of continuous GPS, ODBA, acceleration, and environmental indicators. And you don't need to recapture it. This is a typical example of turn research, which gives more than 100 GPS in average per day. And you have all the other types of data. And the research just installed a hub on a small island during its flyway to remotely and automatically receive the data and upload the data for the nano. This is how the hub works. It functions as a relay between the nano and the cell tower. You can easily place the hub somewhere outside in open space. Somewhere high would be better. It is waterproof and with a big battery, and it can be recharged by a power cable or solar. And the signal range could be as far as 1.5 kilometers. When the nano flies into the range, the hub will automatically obtain its data and upload. This is good for breeding site research. And since nano has big memory, can also record migratory tracks as long as it will eventually goes back to the site. Hub also has many interesting applications, which makes the tracking even more comprehensive. For birds at breeding sites, if you put a hub near the nest or colony entrance, you can get accurate records of the time it enters or exists the nesting area. It gives you the statistics of the nest-related behaviors, how the parents take shift taking care of their babies or eggs, or what is the foraging pattern during the breeding period, or does the parent have fidelity problem, something like that. Or you can choose to carry on your backpack and connect your mobile phone to it via Bluetooth. Then you will be able to see on your phone screen when a tagged bird comes near you, and you can use the phone to do some operations on them. And hubs can also be used to solve many other problems. For example, you can also set that when the bird is in the nest or colony, I want the device to stop working to save power and resume working again when it flies out. And you can do it with hub. This is a very flexible power saving scheme, can be used for even nocturnal or hibernating animals. You don't need to set a rough period in advance. It will automatically detect that. Or you can combine these two settings to make it even precise. You save the power to the most extent and without missing any valuable data records. For even smaller species, which can only bear tiny tags, we can also use the hub to do trilateration. For example, in an intertidal zone, say 1 kilometer times 2, you will need to deploy about 8 hubs. Then the tracker on the birds can get accurate positioning by measuring the signal from the hubs, not GPS. Thus, tracking birds under 50 or even 30 grams will be possible, and it will still give you other data types. You may wonder, what if the bird flies away? Can I still receive data? The answer is yes. You just need to deploy the hub along the flyway, and we think it's feasible because we're able to control the cost and make it affordable to deploy a lot of such hubs along the Flyway for your scientific project. And it's definitely worth to do because it's just like the charging piles for the electrical cars. Next, I'm gonna talk about fine behavior analysis. Fine can be the opposite of comprehensive, and it can also be a part of it. Firstly, with high resolution data, you will be able to generate this individual flight animation like this. So I don't have much time, so I'm gonna pass this. Secondly, you can visualize the data on the web page or for correlation. Here I give two examples. On top is a comparison between the speed and height. I was always looking at this and imagine how the bird adjusts the speed for different landform. On the bottom is a case of a mortality detection. This is one in winter. This clearly showed that the device has fallen off or the bird died. At a certain point, the device cannot detect any activity, and the temperature dropped because it's no longer supported by the bird's body temperature. The third is ODBA. This describes how the activity intensity changed a long time for each individual. It is based on the 25 Hertz acceleration. The computing is on board, so you get continuous ODBA output, which is very, very valuable for long-term behavior research, such as activity rhyme and energy utilization pattern. So here is an example of 1 day and 1 month. If you want to do even fine behavior research, you can also have the raw acceleration data. Here is an example. When you check the GPS track, you want to know what the bird is doing there. So you click into it and the raw acceleration is in the three exile XYZ. And you can, on the right, you can create behavior tags for it. Whether it is flying, resting, or foraging. And what you can get from this raw data with marks, which is the foundation of behavior algorithms. When you have the algorithm, you can write it into your device. And so it is able for you for the device to compute and output continuous behavior tags, just like the ODBA. And this is what we call the AnyAct algorithm platform. With this, we can finally achieve the comprehensive tracking, which enables us to know where the birds are, what is their surrounding environment like, and what birds are doing. Yeah, I think my time is up. So thanks very much.